All right, so we should be in, oop, that's the wrong one. All right, so we should be in Bell 7 and then, or whatever Bell, and we're going to be in the week 4 folder, Intro to Adams Notes. Click on it. Then you're going to go to My Document. And then this is what we're going to be working on right here. I posted the link to the Nearpod in the chat. So you should be able to click on that and go to the Nearpod, where we'll be going over the notes and everything for today. All right, I have 8 people signed in. I'll post the link one more time. All right, so here we go. So we're going to be starting today on atoms, and I asked you to draw what you think an atom looks like. So here's a pretty good one from Will. All right, he's got the nucleus, and he's got the electrons going around the outside of the atom. I like it. Pretty good. All right, so I like what I'm seeing. So we're going to be talking about atoms today, and this is where we are going to start our dive into chemistry. So I said physical science is part chemistry, part physics, part astronomy. This is the chemistry part, and it's a big part. So atoms, this is the building block of everything we're going to talk about from here until Christmas. So we need to get really good understanding of this and what atoms are, how they behave, what they are made up of, and everything like that. And it's actually pretty interesting. So atoms make up everything in the universe. Atoms are made up of matter. Atoms make up matter. And matter is anything that has mass and takes up space. So like I told you guys earlier, that when you see bold words that are in color, those are the ones that go in the fill in the blank. So on your screen, all right, you're going to go to this first one. You're going to double click on the yellow box. When you double click on the yellow box, it highlights the whole yellow box, and then you start typing. Okay. And then energy was the second one. So when you double click and start typing, it'll fill in the words that you type by double clicking on it. And this is what you're going to do for each slide. So on this slide, all the information that was there was matter and energy. So that's what you fill in the boxes. Okay? All right. So let's go back to the Nearpod. All right. So matter is anything that has mass and takes up space or has a volume. So brick has a mass and takes up space. Desks, pencils, airs, cell phones, you, right? You have mass and you take up space. So don't let anyone tell you that you don't matter. First of many bad jokes coming your way this class. So Matter has space and takes up and has a mass. Energy is the currency of matter that can perform work. So energy is not matter. Energy is things that is like the money that matter needs to do work. So like I said, if you want to pick up that desk, that's matter, you're gonna have to expend energy to do so. Energy, like for electricity, electricity is a form of energy. You can't put electricity in a bottle and pour it out. Okay, it doesn't take up space. All right, so electricity is an example of something that's not energy or not matter. So, and things that are like ideas or concepts, like the internet or an idea you have, those aren't matter either. Those are different forms of energy. So energy goes into the second box. Now we're going to we're going to focus on matter for now. So matter is made up of atoms. Atoms are the smallest possible unit which matter cannot be divided down into. So if you can't break it up any smaller, you have an atom. And atoms can be broken into subatomic particles, but the subatomic particles are not relative to each type of atom. They are just pieces, like puzzle pieces, that fit together to give atoms their characters. So, for example, water is made up of H2O. So it's H2's two hydrogens and one oxygen. You can split that in the middle, and you can break up the hydrogens and the oxygen. All right, and then those bits cannot be broken down any farther. You can't break down oxygen into anything other than oxygen. So oxygen would be an example of an atom. And atoms are really tiny. Okay, if you were to draw a line from your shoulder to your fingertip, that's about 1 meter. In 1 meter, you could fit 10 billion atoms next to each other. 10 billion atoms. Okay, so think about how much a billion is. 10 billion atoms would fit on a line from your shoulder to the tip of your finger. That's a lot. So atoms are really small. They're so small that we can't even see them because they are smaller than wavelengths of light. So they're practically invisible. Now, it doesn't mean they're not there. If you want to know that they're there, you can move your hand back and forth in the air, and you can feel the air hitting your hand. Okay, the air is made up of atoms. There are atoms in the air, there are atoms in the desk, there's atoms everywhere. Your body has octillions worth of atoms in there. So there are atoms everywhere, and they're made up of these subatomic particles, and these subatomic particles give them their characteristics. So the first of three is a proton. So proton is a large part of the atom, and it is in the center of the atom, which is called the nucleus. The nucleus is the center space in there. It's where the protons and the neutrons hang out. Protons have a positive charge. So if you ever, because I'm going to ask you what charge does a proton have on some quiz or homework or something in the future. You can bet on it. So if you're having trouble remember it, just remember a proton is positive, positive. If you are pro, you are good at what you do. You are professional. Pro are good, and you can think of good as positive. It's a good way to remember that protons are positive. Now, protons tell us the atomic number as well, and the atomic number is something that we humans came up with in order to organize these elements. And the atomic number identifies the element. So the atomic number is the number of protons that are in its nucleus. So the atomic number tells us the number of protons that are in the nucleus. So if you are keeping up, you should have this done. So this is what your sheet should look like so far. All right. So let's see how well you're paying attention. So again, if you don't know what to do, look at your notes. Your notes have the answers. All right, so look at this picture. It's on the Nearpod. If you're looking at a picture of the atom and you notice that there are 10 protons, what is the atomic number? So if you look at this, you can see that there's 10 protons, 10 neutrons, and 10 electrons. So what is the atomic number of this atom? Close, but it's look at your notes. Remember, your notes say that the atomic number is equal to the number of protons. So how many protons are in this atom? Yep. Here you go. 10. Very good. And you guys are going to learn how to associate that number with an element when we cover the periodic table. All right, neutrons. Neutrons are neutral, thus the name. Think about the name, it's right in there. Neutron, neutral. If you're neutral, you don't have an opinion either way, just like neutrons don't have a charge. Neutrons have no charge, they are not charged at all, but they do help make up the mass of an atom, and they're also in the nucleus. The reason they're in the nucleus is the same reason has the same principle as a magnet. So have you ever taken a magnet and put the two positive ends together, what happens? Type in the chat or shout it out. If you have two positive ends of a magnet, what happens? Yes, Terrence, good job. They repel. So, yes, good. So, just like that, the protons will do the same thing in the nucleus if they're left by themselves. So the neutrons act like spacers between the protons so they don't repel each other. If they repel each other, the whole atom will fall apart. You won't have anything left. So the neutrons are like buffers between the protons to keep them in the atom. So the neutrons are neutral and they go in that blank. All right. Neutron walks into a bar, asks for a drink. The bartender says, "It'll be free, no charge." Do you get it? Oh, come on. All right, guys, get it? A neutron. goes into a bar. A neutron is neutral. Neutrons don't have a charge. So that's why there is no charge. The drink is free. Ah. Ha ha. There we go. There's the answers I'm looking for. There's lots of science jokes. I appreciate good science jokes. And you should too. All right, next up, electrons. So electrons are the last subatomic particle. They exist on the outside of the atom, so electrons are not in the nucleus. They float around the outside of an atom. So they are negatively charged. So these are if you think about it, electrons are the opposites of protons. Protons are large and they're positive and they're in the nucleus. Electrons are small, negative, and they're outside the nucleus. So they are the opposite of a proton. Electrons are the opposite of a proton. Electrons fly around the outside of an atom very, very fast. So fast that scientists can't even really predict where they land. So they are existing in these clouds, so to speak. This model of an atom over here is a very, very simple one, just so that you understand where the protons and neutrons and electrons go and how the size relates to each one. If we look at an electron cloud, let me find a good picture. Here's a good one. Come on, internet. All right, well, let's look at this one instead. So if you look at this picture here, on the right, you can see the electrons are kind of flying around, and they are divided into these what look like rings. All right, this is a more accurate representation of an atom, but we keep it simple with the ones that we use in this slide. So valence electrons are an important type of electron. They're the electron that are on the last outside ring here. So they're important and they're used for bonding and the reactivity of each atom. So atoms will swap these electrons, or they will straight up take them or share them, and those properties are based on these valence electrons. So the mass of the electrons is so small that we don't count it in the mass of the atom. So electrons and valence electrons should be on your sheet. All right, so how many valence electrons are in this picture? So look at the picture. Look at the definition that you saw for valence electrons on your notes. Then tell me which one or how many valence electrons there are. Yep. All right, we're gonna need to take a look at this one. So this asks for the number of valence electrons. Now the definition for valence electron says, valence electrons are the electrons in the outermost energy level. The outermost energy level. So that is, each ring is an energy level. So the ones on the outermost energy level are right here. That's 1, 2, 3, 4, and 5. So the correct answer is 5, the outermost energy level. All right. So another quality of atoms is they have a mass. So they do have a mass even though they're very, 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 very small. So the mass number is equal to the protons plus the neutrons. The mass number is equal to the protons plus the neutrons. So if you look down here on this atom, you can see that there are 3 protons and 4 neutrons. Therefore, 3 plus 4 is 7. So the atomic mass, the mass number is 7. 3 plus 4. Now, the atomic mass is slightly different. We're not going to talk about atomic mass much, but sometimes I accidentally interchange mass number and atomic mass. All right, and I just want you to know that they're approximately the same thing, but the atomic mass is the average number of masses of all naturally occurring elements of that atom. So, for example, carbon has an atomic mass of 12. That means if they weighed all the carbons in the world, the average mass comes out to about 12. Which is the number of protons plus the number of neutrons. All right. So, let's see. All right. So, very, very simple math question coming up. You have 30 seconds to answer it. All I'm asking is, do you know how to answer it or not? Yes or no? So x plus 6 is equal to 10. All right. So everyone knows how to answer this. Everybody said that they did. So you subtract 6 from both sides, which gives you 4 remaining. I want you to apply this logic to this first question on this quiz. Not the second question, the first question. All right, so you got a 2-question quiz. So in order to find the number of neutrons in an atom, you will subtract the mass from the protons, which is the atomic number. Because the atomic mass, the mass number, is equal to the protons plus the neutrons. Therefore, if you subtract the atomic mass from the number of the atomic number, then that remainder is the neutrons that are in that atom. So answer the first one, and don't answer the second one yet. All right, so then what would the difference, I said don't answer the second one. Because this is a simple type of question that I will ask you in the future to say how many neutrons are in the atom iron. And then you're going to look at the periodic table, you'll find the atomic mass, you'll find the atomic number, you'll subtract them, and be left with the neutrons. So mass number, so this is just like that last problem which was 6 plus x equals 10. This is 6 plus x equals 12. So you guys all told me you know how to solve that. So do the same thing here. Subtract 6 and 6. The answer should be B. All right, so next up I said that you need to know the protons plus the neutrons is equal to the atomic mass. So if you have 9 protons and 10 neutrons, what's the mass of fluorine? Now you can answer B for the second question. If you have 9 protons and 10 neutrons, what is the atomic mass? So the correct answer was C. 9 plus 10 is 19. All right, so the reason why I had to do that is because we're going to talk about something where you have different number of neutrons, and the mass is really important for this. So an isotope is a type of atom where two atoms have the same number of protons, but they have a different number of neutrons. This is the next blank you should be writing down. So the same number of protons, but different number of neutrons, because if you change the protons, you change the atom. If you change the protons, you change the atom. So in this one, if you add more neutrons, all you do is you increase the weight of the atom. You don't change how it behaves. It's still a hydrogen atom, but if you add 1 or 2 neutrons, you still have hydrogen. It's just a different type of hydrogen. So isotopes are the same number of protons, but they have a different number of neutrons. And remember, you can change the number of neutrons in an atom and still keep the same atom, but if you have a different number of protons, you have a different element altogether, and that changes everything. All right. Next up, ion. Ions are when atoms gain or lose electrons to become stable. It's when ions gain or lose electrons to become stable. So when they swap around electrons, if they can gain them or get rid of them, but that makes them become an ion. So in this picture here, you can see that there are 8 protons and 6 electrons. This one has 2 more protons than it does electrons, therefore it will have a +2 charge. We'll get into charges and all that later, but an ion is a charged particle that has gained or lost an atom. So this is another blank. So there are 2 different types of ions. One ion is called a cation. It's positively charged, and there are more protons than there are electrons. So in cation, the atom gave away electrons and became positive because now it has more protons than it has electrons. An anion is an atom that took on electrons, like absorbed electrons, which will then make it more negative, which is an anion. A good way to remember that is that cats have paws, and cations are positively charged. Ha ha. Ha 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 ha. An anion kind of sounds like onion, so I think onions are bitter. So cations are positively charged, anions are negatively charged. And that should take you to the end of your notes. All right, so we're going to play a little game and see how it goes. All right, so before we play this game, I want to make sure that you guys can submit your work on Schoology. So go ahead and submit your notes on Schoology. Once it's filled out, you should hit this big white button up here that says submit, and then your notes will be submitted. And that's how you get a grade for today. All right, guys, so if you need any of the missing information from this, what you're going to do is if you go to the assignment part and you click on this Nearpod Atoms link, it'll take you to this presentation where you can look through and find whatever vocab words you're missing. And then when you're done, please make sure you submit the document, otherwise I cannot grade it. If you have any questions, feel free to come to my office hours, which are up next from 11 to 11:50. Also, I want to remind you guys today, while I have you all here, that the test prep is today at, I think it's 1 o'clock. Yeah, today at 1 o'clock, sign back into this class at 1 o'clock to do the test prep. It's pretty simple. All you do is make an account and then answer, do 2 or 3 of the quizzes, and you call it a day. Pretty simple. So make sure you guys all come back at 1 for the test prep. And if you need me, I will be in my office hours from 11 to 11:50 today. All right. So with that, that's all I got for you guys today, and you're free to go. Are you looking at my screen? Right here. So it takes you to a Nearpod that you control, and then you can go scroll through it and find the ones you missed.